What's up everyone, welcome back for another AP Stats review. So in this video we've been going over confidence intervals, which is chapter 8 and chapter 10. Alright, so first up we have mean. So the formula for mean, we have our point estimate, which is x bar plus or minus either a z critical score or a t critical score. In order to figure out which one to use, you have to look at your standard deviation. If it's a sample standard deviation, you use a t critical value. If it gives you the population standard deviation, you have to use a z critical value. So whatever standard deviation you have, that determines which type of critical value you use. And this is the rest of the formula. All right, next, these are the 4 steps. So for state, you have blank percent of the confidence interval for mu, where mu is a true mean of blank. So you have to define what mu is. We're using mu because that's the parameter. We're using the point estimate in order to find our parameter. All right, so then plan is either going to be a one sample z mean CI for mu or one sample t mean CI for you. And again, previous slide is whatever standard deviation you have. Conditions is either you have random, normality, of independence. To figure out if it's random, it's most likely going to be stated. Normality, the sample size has to be greater than 30. However, if it's less than 30, you have to go and see if there's outliers or if it's strongly skewed on a graph. And then independence and the population has to be greater than 10 times sample size. For the do part, you just use these formulas, and conclude, you just fill in the blanks. All right, so for an example, here's this, I just highlighted the important stuff. All right, so state. It says we're using a 90% confidence interval, so we're going to use 90% confidence for mu, where mu is a true mean of the weight of Oreo cookies. The plan is going to be a one sample t mean interval for mu. The reason it's t is because we have an S of x. S of x is a sample standard deviation. So sample standard deviation goes with t. Right? And then condition that's stated is all the conditions are checked out. And then for the do, you have x bar plus or minus the t star times s over square root of n. And you just plug in these values back into this equation, and then the highlighted part is our confidence interval. And then so if you're trying to calculate your t critical value, what you want to do is you want to get your chart out, or you want to go to inverse t. If you're using the chart, you do n minus 1 for your degree of freedom. So in this case, our sample size was 36. 36 minus 1 is 35. So our degree of freedom is 35. But on our chart, we don't have a 35, so we go to the lowest one that's closest to 35, which is 30, and then that's how we get 1.697. Or if you go to inverse t on your calculator, the area in this case would be 0.05, because anytime you're doing the t or z, you have to use the area of the tails, of the curve. So if we're using 90% curve, there's 10% left. And so 10% divided by 2 is 0.05 on both sides. So that's what you put for your area, and your DF is 35, and you should get something really close to 1.697 as your T. And that's that. All right, proportion. This is the formula for proportion. Proportion, you're always using Z, no matter what. So yeah, pretty much. And then this formula for standard deviation is P hat Q hat over N, all under the square root. All right, so 4 steps. Very similar to mean. Instead of mu, you're just putting proportion. Remember, you're not putting p hat because we're trying to find a parameter, so you just use regular p. Planned one sample z proportion, that's always going to be that. Conditions are the same except for normality. Normality, you're going to do np hat and nq hat, and they both have to be greater than 10. To do this formula, conclude, and the same thing. Here's another example. Important stuff. Yeah. All right, so you're using 90% confidence interval for P, where P is a true proportion of seniors attending prom at Tanya's school. Plan, one sample Z proportion, CI for P. It's supposed to be P. My bad. Messed up there. Anyways, conditions. It's stated, so that's good. Normality. Once you plug everything in, yeah, everything should check out. For the do part, P hat. Yeah, everything. Here's the equation, and so if you want to get p hat is equal to x over n, And our x is 36 and our n was 50. So 36 divided by 50 is our p hat, which is 0.72. And in order to get q hat, it's just 1 minus that, so it'll be 0.28. How to calculate z critical value? You go to inverse norm on your calculator, and the area is the same thing, area on the tail, so it'll be 0.05, and that's how you get 1.65 as your z critical value. Then you just put everything in the calculator and for those variables, and you get the highlighted, which is the confidence interval. Difference of means. We get the formula is this. You're going to do x bar 1 minus x bar 2. Plus or minus t is most likely going to be t. If it's a question on the test, put t. And then for standard error, the formula for standard deviation for difference of mean, you have to add the variances and take the square root of that. So we want to square the standard deviations and then take the square root of all of those. 4 steps. The state is similar, just like what you're trying to find is different. You have to define both variables. For plan, it's going to be 2 sample, t difference of mean, ci for mu1 minus mu2. You want to be really specific when naming which type you are doing. Conditions, when you're doing 2 samples, you have to make sure the conditions are met for both. So you have to use these 3 conditions on both the first population or first sample and the second sample. Then for do, using this formula. Conclude, yeah. Okay, example there, yeah. So using another 90% confidence interval, and then I defined which each parameter we're trying to find. Plan 2 sample, t difference of mean, ci, yeah. Okay, so conditions. I made sure I found. I made sure that both of the samples are checked out, and which they do, as you can see in the bold. And then I plugged everything in back to that equation. All the numbers are here. All right, and this one, so whenever you have 2 different samples and you're trying to find a t critical value, you use something called the conservative, which you just use the lowest sample size. So if you look here, the lowest sample size here is 621. So you just do that df. So 621 minus 1 was the 620. If you look on the chart, you're going to go down to 100 because that's the lowest one, that's closest. But if you use the calculator, you just inverse t. You put 619, 620 as a df, but the area would be 0.05. Difference of proportions. Proportions, p hat 1 minus p hat 2 plus or minus z. It's always going to be z since it's proportion. And then standard deviation for proportion is p hat q hat over n plus p hat q hat over n, all under the square root. 4 steps, like we've been doing before. Make sure you define each variable. We are dealing with 2 samples here, so that's why it's called 2 sample. Z z because it's a proportion, and yeah, conditions for both. Make sure these three are met. And remember, for proportions, it's NP has to be greater than 10, NQ has to be greater than 10, not N has to be greater than 30. So make sure that's right. Do this formula, conclude. Yeah, here's another example. Yeah, so this time we're doing a 99% CI, and I defined both of the populations, the samples in order to find our populations. And then I checked out the conditions, and all of them were good. And then I plugged everything into the calculator, and I got this highlighted interval. And now for the blue lines, PN minus PB. Again, if you don't give a percentage, it's going to be X over N. And so as you can see, you have 40 subjects and 240 for nicotine. So that's 40 over 244. And the other one, you have 87 and 245 bupropion, whatever. Anyway, so you do those. Divide those to each other, and that's how you get those percentages. And then you just plug those in, and yeah. Okay, and then we have paired data. And this is our mu of diff. And here are the formulas for this. Either going to use a z or a t, and most likely is going to be t. Remember, it all depends on your standard deviation. If it's a sample, use t. If it's population, use z. For state, it's really the exact same thing. But the only kicker here is it's going to be a one sample because it's all being condensed into something. So it's a one sample Z or T, most likely T. And then conditions are the same as for mean, and formula is this. And yeah, just conclude like you always do. Thank you for listening. Please like and subscribe. See ya.